Okay, now I'm sharing my presentation, I hope. You have to, well, shout out if you can't see it. This presentation is about measurement of hydrogen, and focused on custody transfer, that is large scale, large volume transportation. My name is Kjetil Folgerød. I work in the Measurement Science Group in the NORS Energy and Technology Division. We have a history where we have worked a lot on natural gas and oil measurements and uncertainty analysis. Here we go. The outline of the talk is that I'll first talk a bit about the hydrogen infrastructure when it comes to transport of hydrogen. We'll touch upon the different metering challenges that we see related to hydrogen custody transfer. And the main part will be on the research projects we have here at NORS regarding metering for hydrogen. Page down is not working. Here we are. Okay, if we look at what the European Union and the International Energy Agency thinks about hydrogen, they say that it will be an important part of the green shift. In the EU, they plan for an import of 10 million tons already by 2030, and in addition to produce another 10 million tons themselves within EU. As you can see on in the figure to the right here, which is a global forecast by the Norske Veritas or DNV, you see that today we are not producing much, but that will increase steadily and very fast from 2030 approximately. What we also can see is that the main part of or a large part of this increase will be industrial usage of energy and also into transport for long distance transport, first of all. So, okay, so if that's gonna happen, that means that we need to build a new value chain here. We need new production facilities, new storage and distribution facilities, and also new applications coming in. And all this has to happen at the same time. Different people have looked into this and to see how the transportation can be made most cost efficient. And it seems for Europe at least, that pipeline transportation will be sort of the main distribution method. Here are some planned infrastructure projects, and you can see some of the pipelines that are planned today. One of the initiatives is the European Backbone Network, which consists of all European energy infrastructure operators, 33 of them, come together, covering 28 countries in Europe. And they are at the moment planning for this kind of structure in 2030. For instance, they are planning for 5 different import corridors, one from Norway/UK, further from Baltics, and also from south from Africa and also other places as well. So, and one of these corridors will maybe include the Norwegian the pipeline that is have been studied from Norway to Germany, where it's a feasibility study carried out by Gasco and DNA, where they plan to produce blue hydrogen or low carbon hydrogen in Norway, in Nyhamna or on the west coast of Norway and transport that to Germany. In addition, we might add some local produced offshore hydrogen coming from wind parks on the way. So what we see is that at the moment, most of the hydrogen is produced locally and applied locally. So most of the pipelines that exist today, they come from a local producer to a single industrial user. That means it's quite easy to know who will get paid how much. In the future, the hydrogen pipelines will be integrated in a much more complex energy grid. We try to illustrate that in the figure to the right here. It would be a mix of different transportation means, where pipelines will be sort of the main thing for long distance transportation or medium distance distribution. Anyway, to make hydrogen a commodity, as EU is planning for, there is a need for accurate physical measurement so that the seller and the buyer gets the correct and fair billing. That's the thing about custody transfer. We need to know that everybody is happy. So we need to measure accurately. Okay, when it comes to hydrogen metering, we want to adapt measurement technology from the oil and gas industry. There's a long history of how we can measure natural gas with low uncertainty and high reliability. The challenges with hydrogen is that the properties are quite different, well, a bit different from a natural gas. The meters will respond differently, so they may be tuned or adapted for hydrogen. Further on, there is a lack of industrial experience in the metering issues here, and when it comes to calibration and test facilities. Further on, also due to this, there's a lack of knowledge of the actual uncertainties and the technological risk regarding the different meters that will or may be applied. And lastly, the regulations are not in place, and the standards that the meters need to follow are not quite yet there. So the sort of the research question or basic question here is that knowing that you need to build this, how can we do it? How can robust and cost-efficient measurements of hydrogen along the supply chain be ensured? To dig a bit into the hydrogen properties here and how they differ from natural gas. Well, hydrogen is the lightest molecule we have. So the density is much lower, the viscosity is lower, well, the speed of sound is higher, some examples. And all this will affect the measurement, well, the measurements, what we measure by the different measurement technologies here. And that again will affect both the uncertainty of the different meters and also the operating range of the meters. Down here we've drawn some of the meters that we are considering when it comes to and that are potential meters to be used for hydrogen measurement. All of these meters are used today for measuring natural gas transportation. On the left-hand side, we see venturometers, which measures the differential pressure over a small insert or change in dimension in a pipeline. That will be affected. That will be different when it comes to hydrogen instead of natural gas. The next one here is the turbine meter, where the rotors are rotating according to how the flow velocity goes through here. That will also be, the operating range of these will also be affected by for instance, the viscosity changes and so on. The Coriolis meter, next one, that's measuring directly the mass that goes through here, which will also be affected and might have to be tuned somewhat to respond or to be dimensioned to work with hydrogen instead of natural gas. The last case here, that's the ultrasonic meter that was mentioned earlier in the introduction here. And what we see here is that, for instance, that the speed of sound in the hydrogen is much higher than for natural gas, which means that the transit time of the signal will be shorter. That might, well, it will affect the measurement uncertainty and also the operating range if you don't do anything with the technology. So you have to adapt it. You have to either increase the lengths or do something with the measurement frequency. That's an example of technologies and how they are affected. Other things were other issues with hydrogen compared to natural gas. That is, that if you want to transport the same amount of energy as you do with natural gas, you either have to increase the volume rate or use a much higher pressure due to the less energy content per volume in hydrogen, natural gas. Then hydrogen is a very small molecule, as we mentioned, which means that there is an increased risk for leakage. So we have to ensure that there are no open spaces or gaskets where the molecule or the leakage can happen. The ignition energy is much lower for hydrogen than natural gas, so we have to consider the explosion safety. And also hydrogen embrittlement may be a problem. So we don't know. We have to select the material for the meters such that they can perform over a long time. That's another one. This should be hidden. Okay, let's take a look at the projects we have here at Norge when it comes to hydrogen metering. We actually have 3 projects or 3 activities going on. The largest one is I'm going to talk most about. That's what we call HIME. So I'll start there. That's the competence building project called hydrogen metering, which started last year. This is funded by the Research Council of Norway, but partly funded by the Research Council, and also by the project partners putting in either cash or some in-kind contribution. So the project partners is Shell, Total, Equinor, Gasco, Justervesenet, and the research partners here are University of Bergen and NORS. So what we look at is we have one work package on the metering technologies themselves. So we want to figure out how do the different metering technologies respond to hydrogen, how will the uncertainties be, or how will the technical risk be for those meters. The next work package is on the measurement station concepts. That is, how do we combine different meters at different measurement points along the supply chain. Then we have a work package or activity on traceability and calibration of the meters, because that's, I'll come back to that. And the last one, we will look at losses and quality degradation throughout supply chain. The specific goals we're working at the moment is, first of all, to map the different meter technologies with regard to status, where they are, and the potential towards some end user cases that has been defined by the project partners. Also, we want to collect all the information we get in and the calculations we do into a framework, a software framework for design analysis of hydrogen metering stations. And the focus there is on uncertainty and technological risk. The project partners here are very focused on high volume transportation of pressurized gas, hydrogen gas in pipelines. So that's the main focus in the project. And of course, then it's custody transfer that is of interest. Here's a bit more detail on the first work package on the metering technologies themselves, where we map the status. A measurement system or measurement station typically consists of flow measurements to understand or to measure how much that is transferred through the station, and also some means of measuring the quality of the hydrogen that is transported. So we are mapping both flow and quality meters. And we are looking at the applicability, where can it be used, how ready is the technology for implementation. We're looking at the operating conditions, what kind of flow rates are we talking about, what temperature, pressure ranges, are there any mechanical restrictions with this kind of meter? And of course, we look at the performance, uncertainty values, how will impurities affect the measurements, with the pressure loss through the meter be large, and so on. And then we also, there are several things we map each technology against. And we do this by talking to vendors, digging into literature, doing a lot of calculations ourselves, so on. The next work package is on the metering station, where we want to combine it. Here on the right-hand side, you can see a drawing of a typical metering station where we combine two different flow meters in parallel with an online GC for measuring quality. That's a typical situation of a custody transfer metering station, but it could look different. Could be another measurement technology, and it could also be meters in series instead of in parallel. So what we do in this work package is to, well, first of all, put up some realistic supply chains. We have looked into all the plants that are in Europe. We have discussed with the partners how they foresee to build their pipeline systems, what kind of flow rates they expect, and what kind of qualities they expect to transport. So we analyze that. We look at the sensitivity and the uncertainty of the complete metering station. And we also aim to develop a software tool for this. And here an example of the tool that is under development, where we can read in data for a given metering station, how the volume is, how that is with time, how it changes with time, and also how the quality changes with time. And then we can configure a metering station for that and do some risk and uncertainty calculations of that. This is just an example. The work package on traceability and calibration is more related to, well, we have a meter. How do we know how accurate it actually measures? That and here we play along with Justervias, who is sort of the experts on this, because they can transfer. Well, they are working on the transferability from, well, all the way back to the SI unit, and then through national standards, laboratory standards, and so on, all the way up to the measurement that is in the process. The trouble now is that there are not very many calibration flow loops available for hydrogen. Most of the ones that are there are for very low flow rates, and therefore cannot really be used to test the high volume meters that we want to examine. There are some that are coming up, have started. There is one that started last year. That's about it in the world. So there's a lot more to do. We also have a work package on losses and quality degradation throughout or along the supply chain. And here we have a PhD student at the University of Bergen who's focusing on this part of the project. So the idea here is to, well, identify high-risk nodes for losses and degradation of quality. We want to look at how quality could be found in a more cost-efficient way than is done by the large GC measurements, so on. We will look at the mass and energy balance throughout the supply chain, and so on. As an example, we see that when you store the hydrogen in, for instance, subsurface storage facilities, that will affect the quality of the hydrogen. So the question is, how can we ensure that it's below certain limit, and how can we measure it efficiently, and what needs to be measured? Okay, that was the first and really the largest project we have. Then we have another project here called Metrology for the Hydrogen Supply Chain, which is a European or EU project. It's a European partnership on metrology that is called Euromet, that is supporting this project or funding this project. Here we are 27 European partners. From Norway, it's Norse and Justervesenet is taking part. We at Norse are heading the work package 4 here on measurement uncertainties, and Justervesenet is heading work package 2 on flow measurements. Then there are also work packages on hydrogen gas qualities and other supporting technologies for hydrogen. What we look at here is more two things. It's the more fundamental things. We look at time correlations, other correlations within the measurement, so that we can ensure that the uncertainty is as low as possible. We see how that affects measurements. And then we also dig into some case studies on example supply chains. And at the moment, we have listed 4 case studies we will go into. It's the first case here is hydrogen enriched natural gas, where you can put up to 20–30% of hydrogen into the natural gas and transport it along the already existing pipeline systems. That will affect uncertainty. We will look into how. We also have planned a case study on liquid hydrogen. The trouble here is to get data from real data for this, because we don't want to do this as a theoretical study. We want real data to examine. And for liquid hydrogen, it has not been easy to get that. So if you know anybody, please give me a call. Then the 2 last, that's high volume industrial transportation through pipelines we're looking at. We are also looking at the local refueling station, it should say, how the uncertainty of such a system will be. Okay, just one slide for that project. And The last project or activity we have is a part of the high value FME center that Norse is heading. And here we have a task called robust metering for supply chains. And here we have two focuses. Well, one is to cooperate with the or spread the information from the HIME project over to the High Value Consortium and back from the High Value to the HIME project. And then in addition, we have a very specific focus where we look at the sort of indirect gas quality measurements. How can we combine different measurement technologies in order to get information about the quality? What we do here is look at, can we combine ultrasonic measurements of the gas with dielectric or electromagnetic measurements and some optical spectroscopy measurements, and see how we can correlate that to the gas quality. We have several master students connected to this instance. So we have started measuring, well, building and actually getting results on the dielectric measurement system. And that's what I had to say today. It was a quick round through metering. Thank you.
Thank you. Very interesting. And